This is not the first time we've seen this vocabulary. Vocabulary for transformations has been the same since we started learning them in Algebra 1. We've also done transformations of quadratics and absolute value functions, but that was last semester, so I'm sure you need a refresher. This table is going to be very important for you because it has all of the notation as well as which direction everything moves. If you have a horizontal translation, that's going to shift the graph to the left or right. So it's a shift. We're just going to be moving the polynomial function from left to right. Either the u, the little squiggly s, or the w is going to be moved to the left or right. For this to happen, you're going to add or subtract a number inside a set of parentheses. There will always be a set of parentheses, so the number that you add or subtract will go inside of it. So if you notice, in the examples, in both of those examples on this row, there's a number in parentheses. The things I want you to notice about this is that when there is a subtraction sign, it's going to move to the right. And when there's an addition sign, it's going to move to the left, which is a little bit backwards from how we normally think about positive and negative numbers. That's because horizontal transformations are inside and opposite, which is written down here at the bottom of your paper. Horizontal, inside, opposite. Our vertical translations are going to shift the graph as well, although this shifts the graph upwards. So this time you're going to be adding or subtracting a number, but not inside the function, at the very end. It changes the y-intercept. This one is normal though. Up is a plus, down is a minus. There's no trick to remembering that one. The next transformation we can apply is a flip or a reflection. When we did reflections before with quadratics and with absolute values, we pretty much ignored flipping it over the y-axis because it never looked any different. That's because those were even functions, but we didn't know about even functions back then. Now we know about even functions and we know about odd functions. For odd functions, flipping over the y-axis actually does something, so we need to pay attention to this one. To flip over the x-axis, you're going to put a minus sign in the very front, make it a sad equation. To flip it over the y, you're going to put a minus sign inside the parentheses. It actually does something different this time. So again, if it's in front, it's going to flip over the x-axis, so we're going to write the word front next to x-axis. Next to y-axis, we're going to write the word inside, because that minus sign is going to go inside. That's our hint to ourselves. Our horizontal stretches and shrinks are going to occur when there is a number multiplied inside the parentheses. So you see how b is right next to x, and we just talked about arithmetic with numbers, and if two numbers are next to each other, we multiply them. So for horizontal stretches and shrinks, the graph is going to stretch away or toward the y-axis. So we're taking two horizontal sides of it and stretching it out, or making it skinny again. So it's going to make your graph either wider or narrower. So if you are shrinking something narrowing, I am narrowing a graph. So on your shrink, you're going to write the word narrow, because it's going to make your graph skinnier or narrower. If you take the sides of this graph and you stretch it out wider, it's going to take whatever picture you have and make it wider. So a stretch is going to make the graph wider. But that's horizontally. So we grabbed the sides of it, the left and the right side of whatever graph we have, and we stretched it or we shrank it. We can also stretch and shrink it if we grab the top and bottom of a picture. If we grab the top and bottom of a picture, that is called a vertical stretch or a vertical shrink. It's going to change this away and towards the x-axis. Yours says x-axis. I forgot to change mine to x-axis. But again, if you take the top and bottom of an image and you were to stretch it, would the image end up looking narrower or wider? Like, think about a picture of your face. If you took the top of the picture of your face and the bottom of the picture of your face and stretched it, would your face get wider or narrower? Narrower. Same thing's going to happen for a graph. The stretch this time is going to make it narrower. And if I take the top and bottom of a picture of my face and I shrink it, what's going to happen to my face? It's going to get wider. It's going to get really weird looking. So our stretches and our shrinks do different things based on which direction we grab the image or we grab the function. Stretching horizontally makes it wider, but stretching vertically makes it narrower. So that's an important detail. Now, we have seen this vocabulary before, so it should somewhat sound familiar. They're the same exact things. It works the same exact way as it does for quadratics and for absolute values. Something more interesting, though, happens with the flips over the y-axis. That's basically it. The goal of today is for you to be able to identify and talk about transformations as well as apply transformations. So our first question right here says to describe the transformation from the cubic parent function f of x equal to x cubed. This word describe means I'm going to be using words. So we're going to be writing words down for what's happening. All that it takes is for you to identify where the number is in the equation and look at your table for what it's called. So look in your table. If you have a number added or subtracted at the back, what is that called? Look at the table. Some of you have not looked at your table. Where on your table does it say plus or minus at the end? Vertical what? Translation. So this is going to be called a vertical translation, but we're going to use the word shift because a vertical translation is a shift of the graph. It's going to shift the graph 9 units which direction? Down. Okay, and let me prove this to you. I'm going to show you on Desmos just because it displays easier. I know we're supposed to be working on our calculators, and you can see the same thing on your calculator. Just on my screen, Desmos displays easier. Cool, let's go to the next one. The next one's a little bit more complicated because there's not just one change. How many numbers did I put into this thing now? Not a lot, like a couple. 2. The cube is from the parent function itself, so I don't need to do anything about the cubic. But if you look at these numbers, those correspond to 2 different translations. Oops, I just gave you a hint. What are they called? If you have a number added or subtracted on the inside, what is that called on your table? Horizontal translation. Very good. And we're going to say, because this matches the vocabulary of your homework, this is a shift 1 unit. Which direction? Left, because plus goes to the left. Very good. And then you have this one that I've highlighted in red. What does a plus 2 at the end do to it?
Goes up.
Shift it. How many units? 2 units. Ooh, up and down, so it'll be up. On the outside is up and down. Inside is left and right. So we've identified the transformations that have occurred. Let me prove it to you that this is what we're actually seeing. If we go to the third one, there are 3 transformations. I'm telling you that right now. Most of us miss this one. What is this negative doing in front? What is that called?
Vertical translation.
Ooh, not the 5 is going to be a vertical something. That's going to be a reflection over which axis? The x-axis. The numbers in front, or the minus signs in front, sorry, are the x-axis. Minus signs on the inside are going to be the y-axis. Okay, now we have this 5 in front. What does the 5 in front do? So look at your table. Where is there a number in front of f of x? What are those words? It'll be either a vertical stretch or a vertical shrink. So now we just need to look at the numbers. In the examples that we gave you on vertical stretch and shrink, what do you notice about the difference between the numbers that said stretch and the number that said shrink? Specifically talking like about this versus this. What do you notice? One's a fraction and one's a big number. So if the number is bigger than 1, or like a whole number, what is it going to be called? A stretch, which makes it narrower. Yeah, and if the number in front is a fraction, what is it going to be called? Shrink. Okay, so let's apply that here. If we see a 5, is this going to be a stretch or a shrink? It's going to be a stretch. Now, I'm okay with you shortening the word vertical to just a V because we get it. Vertical stretch by a factor of 5. So you have to tell me the number, essentially. Now, the last thing we have here is a minus 2 on the inside. So check out the table again. What happens when you have a minus 2 on the inside? Horizontal translation, so we're going to use the word shift because that matches our homework assignment. We're going to shift it how many units and which direction? Minus goes to the right. So you can look at the examples to help you decide which direction. Those examples have all of the information there in that table. Now this last one is kind of going to be a confusing one. Okay, because we notice we have a number multiplied on the inside. What is the name of the thing that you multiply a number on the inside called? Look at your table. When there's a number multiplied on the inside, what is that called? Horizontal stretch or horizontal shrink. Cool. So we see on here that we have a fraction. If you look at the fraction example on there, so if we notice on the table, you have a fraction. So what is that fraction going to be called for this one? Is it going to be stretch or is it going to be shrink? Stretch, because the fraction is on the stretch example. Okay, cool. Well, here's what I want you to notice. Look at these numbers. When there was a 2 on the inside, I said shrink by 1/2. What? When there was a 1/2 on the inside, I said stretch by 2. Why do you think I did that? How did I go from 2 to 1/2 and then 1/2 to 2? The reciprocal. When you're doing horizontal transformations, it's always the opposites. So the opposites for fractions and whole numbers means that they are going to be reciprocals. So when we write this down for ourselves here, we're not going to say horizontal stretch by a factor of 1/2. We're actually going to say that it's a factor of 2. So the horizontal ones are confusing because you have to flip the number over. Okay, so whatever number is there, if it's a fraction, flip it over. If it's a whole number, flip it over. Put it over 1, under 1. Okay, but that's not the only thing we have going on here. What's going on here? What is that called? Vertical translation. So it's going to shift the graph which direction? Down 4 units. Okay, cool. Now that is describing. So when we were describing, all we did was locate the changes or the numbers in the formula and looked at the table for the words that go along with it. Do we feel like we can do that? Okay. The next two are going to ask you to write a rule. So this time we're actually going to be writing an equation. And you're probably thinking, wait a second, Ms. Quigley, they already gave me an equation. They gave you an equation in function notation. Notice that you have g of x and f of x in the same equation. That's fine. We can still write an equation. We just have to substitute back in the parent function. And what I mean by that is, since right here we are applying a minus sign on the inside, because look at the shape, I mean it is minus on the inside. What you're going to do is you're going to write a function, g of x, that's a cubic function that puts the minus on the inside. Like literally that's it. You change it from the function notation f of x to the cubic notation x cubed. You do have to put the parentheses. If you don't put the parentheses, that's technically a reflection over the x-axis. We need it to be over the y-axis. We're going to write that down. This is a reflection over the y. Now, just as a little bonus, because this does not happen with every graph, especially our even functions, if you were to take a number that's negative and cube it, so we're doing, if let's say it's -1, what's -1 times -1? Negative times negative is positive. Then I take that positive number and I multiply it by another negative number. What happens? You don't know what a positive times a negative is.
No, I forgot what you said.
Okay, so if I have 3 negative numbers and I multiply them together, negative times negative is positive, times negative is negative. So in fact, this graph ends up flipping like this. This will not happen all the time, nor will I ask you to reduce it like this, but I just think that that's interesting. Even though we started out correctly writing it as a reflection over the y-axis, it ends up looking like a reflection over the x-axis. That's because this is a perfectly odd function. This does not happen all the time. This is just a weird example. We won't have to reduce number 6, so we can go ahead and do that. First things first, what is this transformation called when there's a number in front of the equation? Look at the table. Vertical stretch or vertical shrink. Is this one a stretch or a shrink? Stretch, because that number is big. It's a big number, the number 4. So when we write our equation to provide a vertical stretch by a factor of 4, all we're going to have to do, and again, we're not going to reduce this at all, is put that 4 in front of your x cubed. So you change out the f of x for the x cubed, or whatever function we're using. So that is your appropriate answer. So when you apply the transformations, you just have to plop the numbers where they go. So far we have looked at a transform graph and said what's happening, and we've taken transformations and applied them to the graph itself. We're going to do that some more, but we're going to do it from words, not from function notation. So this time, instead of having to look at the equations themselves, we're just going to look at the vocabulary. If we want to take a cubic function and we want to write a rule, so we're going to end with an equation, that is a vertical stretch by a factor of 2 and a translation 3 units down. How do we do that? What numbers do I add to the equation to make this happen? So what I recommend is that you always, when you're writing a rule, start off with g of x equal, leave a space, put a parentheses, put an x in like the general middle of that parentheses, and cube it. Because that leaves us space to plop our numbers where we need them. If we want to vertically stretch something, look at your table. Where does that number go? Front, inside, back. Front. Do I add it? Do I multiply it? Multiply. So look, I'm going to put the 2 right there to indicate that I'm multiplying it. That's why I left some space. Looking at the table, if I want to translate something down, where does that number go? Front, middle, back. The back. Do I add or do I subtract it? Subtract. Boom, I'm done. Now you can clean this up because I know we left it kind of spacey. So if you wanted to clean it up, all that you would need to do is multiply it all together. 2x cubed minus 3. That's an appropriate answer for this. Although I would personally accept the one where it's all spaced out. But like, don't put spaces on a computer. That's weird. But for me, when you're handwriting, when you're writing it down, that's fine for me. Now, if we were to look at this graph, though, just comparing it to the parent function, based on the words that I annotated on my graph, this one would be a shift down. And would it be wider or would it be narrower? Look at your table for where we put a big number and a vertical stretch. Does that make it wider or narrower? Narrower. So if you were to identify a graph, which you will be asked to do on your homework, that represents this, you are looking for a graph that is narrower and below it. So shifted down and made skinny. Okay, let's do the same thing for number 8, which means we want to start by writing down a very spaced out cubic function. I want to leave space so I can put numbers where they go. The first thing tells me to horizontally shrink it by 1/3. Okay, this is the confusing one because it's horizontal, which means when I plug that number in, am I going to plug in 1/3 or am I going to plug in 3? 3. Horizontal is the opposite one, so you have to use the reciprocal. It's the flipped. If you want to write that down for yourself, maybe write that down that we flipped the number. Okay, but where do we put that number 3? Front, inside, back. Inside. And I'm also going to multiply it by the inside. So it goes right here in front of the 3. I'm also going to translate this 8 units down. We've already done this one in the last problem. So what do we do to move 8 units down? Where does it go? Outside, and we're going to subtract because it says going down. Okay, cool. We've got one thing left to do. It says to flip it over, or reflect it, sorry, over the y-axis. Looking at your table, where do I put the minus sign for the y-axis? In the very front or on the inside? On the inside. Now remember, it goes on the inside, not in between the 3 and an x, but it makes that 3 negative, essentially. Okay, if we clean this one up, and we're not going to multiply this out, but if we just clean this up so we can see the transformations, I'd write this not spaced out as parentheses, negative 3x, close parentheses, cubed minus 8. Literally, it's the same thing. I just condensed it so I didn't have the random spaces in there. But this graph, if I were to identify it on a literal coordinate plane, should be a flip over the y-axis. It should move down. And it should also do one more thing. Look at your table. For a horizontal shrink, did we write the word wider or narrower? So if we take it horizontally and we shrink it, is the picture of your face that I'm shrinking and stretching going to get wider or narrower? Narrower. So our graph should be, that's not how you spell narrower, should be narrower. So when you visually are checking for these, you're looking for a graph that's skinnier, below it, and flipped over. Okay. Now if you look at the next page, or the back page of this actually, you've seen this image before, and it will be given to you as a hint over and over again in this class. It's got a lot of information on it, but it has all of the places where your numbers go. Notice it has a reflection in the x-axis that's a minus sign in front. The minus sign on the inside is a reflection in the y-axis. The numbers in front, if it's bigger than 1, it's a stretch. If it's less than 1, it's a shrink. So if you're like, I don't understand what that means, here's how you annotate this. A bigger than 1 means that this is a number. A less than 1 means that this is a fraction. If that's helpful for you instead of the math way of saying it. Same way on the inside, if you see that the number is bigger than 1, that's a shrink by the reciprocal. So that's going to be another number. And if the number that you see is a fraction, then it's a stretch by the reciprocal. You have your translations left and right. Plus is left, minus is right. You have your translations up and down. Plus is up, minus is down. We've seen this image before, but maybe we needed a refresher on it. You're going to continue to see this image.